What if I told you there's a hairy crab living where scorching, poisonous hot water gushes from underwater volcanoes, and scientists only discovered it in 2005? Welcome to the story of the Yeti crab, named Kiwa hirsuta. In 2005, a team exploring the East Pacific Rise, an underwater mountain chain marked by hydrothermal vent activity, spotted a strange, whitish creature with hairy lobster-like claws. It looked less like a crab and more like a creature from an alien world. When scientists brought it to the surface, the Yeti crab lived for a short while before succumbing to the cold. It simply couldn't survive outside its toxic, high-pressure home. This discovery widened our understanding of where life can exist. Hydrothermal vents emit superheated fluids up to 400 degrees Celsius, rich in copper, sulfur, and sometimes naturally radioactive minerals. Temperatures around vents plummet to near freezing just inches away. Life here defies logic, yet Yeti crabs thrive. Since that first discovery, similar species, like Kiwa puravida, have been found near Costa Rica's volcanic vents. Yet the first Yeti crab remains iconic. Its hair plays a starring role, but more on that later. Imagine a furry lobster strolling through volcanic fireworks, like a creature from Star Wars, not Earth. This hairy crustacean reveals something profound: life doesn't just exist in favorable environments, it conquers extremes. The Yeti crab is not just a deep-sea oddity, it's a testament to resilience and a reminder that Earth's unexplored regions hold unpredictable wonders. Deep beneath the waves, hydrothermal vents are Earth's pressure cookers. Seawater seeps into cracks in the seafloor, heats up to scalding temperatures, absorbs minerals, and erupts through chimney-like structures, some as tall as buildings. These black or white smokers are toxic freeways for heavy metals, sulfides, and heat. The Yeti crab lives right alongside these vent chimneys, in metal-laced, superheated water. At such depths, 1,000 to 2,200 meters, pressure is immense, up to 200 times what we experience at sea level. Temperatures range from near freezing to blistering hot within inches. Plus, the vent fluids can carry trace levels of radioactivity from uranium and thorium, natural in Earth's crust. Still, Yeti crabs find this environment home. Their bodies tolerate temperature gradients experts can't replicate in labs. They survive water temperatures ranging from near freezing to over 200 degrees Celsius. They endure heavy metal concentrations that would cripple most organisms. How? They cluster near vent openings, limiting exposure, and perhaps use their hairy claws to host protective microbes. Thick exoskeletons and specialized proteins likely help too. By surviving here, Yeti crabs challenge what we believe about life's thresholds. They show that organisms can live on poison and heat, an earthly hint that life might exist in similar extreme environments elsewhere, like Jupiter's moon Europa or Saturn's Enceladus. The Yeti crab's survival isn't just impressive, it's hopeful. If life thrives in toxicity, maybe alien worlds have crabs too. Look closer at a Yeti crab's claws, and you'll find a furry surprise, not for cuddles, but for farming. The crab's pincers are covered in dense hair-like filaments called setae. These soft hairs aren't for show, they're bacterial gardens. Here's how it works: the chemicals spewed by vents, hydrogen sulfide, methane, feed symbiotic bacteria living on the hairs. In return, these bacteria create organic matter, which the crab harvests for food. It's the crustacean equivalent of grazing sheep, but hairier and underwater. Yeti crabs farm bacteria by brushing their setae across their mouthparts, scraping off microorganisms to eat. Different species show different claw structures. The Pacific Yeti crab has numerous fluffy, cream-colored setae. A different species near Costa Rica's vent sports impressive bristly claws. Some scientists think the crabs also cultivate cleaner bacteria to protect from pathogens. We're talking about an underwater rancher. Their tiny mouths are perfectly adapted for grazing these bacterial crops. It's a symbiosis finely tuned over millennia, a biological partnership featuring farming, dental hygiene, and mutual survival. In the brutal deep, cooperation conquers all, even with slime-covered hair. Plus, this behavior expands our idea of agriculture. Who would have guessed farming could evolve underwater, with bacteria, instead of deer and rye? Beyond heat and heavy metals, vents often spew naturally radioactive elements. Yeti crabs hang out in this mildly radioactive stew, again, a place Earth should have declared off-limits. Scientists have found that low-level radiation may help certain vent communities thrive. The Yeti crab's habitat often intersects with zones where uranium, radium, and thorium dissolve into vent fluids. Researchers studying microbial communities in hairs speculate that some bacteria might use radiation to metabolize compounds, or help protect crabs from DNA damage. Essentially, they might be using radioactivity as an energy source or shield. Such adaptations defy biology's rules. How many animals can handle radiation with neither dying nor becoming sterile? The Yeti crab may thus be a case study for evolutionary innovation. Life found a workaround where others see doom. On the evolutionary timeline, their vent habitat is only a few 100,000 years old, but they've already developed unique strategies. Studying these crabs helps us learn how life can adapt, and perhaps escape, dangerous environments. It offers possible insights into radiation therapy resistance in cancer cells, repairing DNA, or even engineering radiation-tolerant organisms. This radical survival strategy reminds us nature's creativity knows no limits. This hairy, toxic-tolerant crab may seem like an obscure ocean oddity, but it holds lessons for humanity. First, it challenges our definition of habitable. Life isn't just sunshine and rain, it's heat, pressure, metal, and radiation. If life can thrive there, who's to say it can't thrive elsewhere under extreme conditions? Second, the crab's bacterial farming hints at sustainable symbiosis. These tiny farmers turn poison into food. What if we could harness similar strategies to clean polluted water, mine minerals, or even produce food in harsh conditions? Third, its resistance to radioactivity and heavy metals could inspire new biotechnologies, engineered microbes, bioremediation, radiation-resistant crops, or medical innovations based on DNA repair. Finally, the Yeti crab reminds us how much remains unexplored. We've mapped the surface of Mars. We've stripped naked genomes. But people are still discovering animals that thrive where sunlight doesn't reach. In a world full of challenges, climate change, pollution, biodiversity loss, the Yeti crab's story is a beacon of hope. It encourages us to think creatively, explore boldly, and believe that even in the worst conditions, life finds a way. What surprised you most about the Yeti crab story? Would you be brave enough to explore hydrothermal vents? Drop your thoughts in the comments. If you found this journey into extreme biology inspiring, hit that thumbs up, share it with a curious friend, and subscribe for more deep dives into nature's weirdest survivors. Until next time, stay curious, stay open to wonder, and remember, Earth still holds wonders beyond imagination.